So moving right along, what we're going to do now is we're going to shift gears a little bit, moving down the supply chain, like I said we would. And we have Professor Vishal Gaur speaking about food waste in retailing operations. So just to quickly introduce Professor Gaur, he's the Emerson Professor of Manufacturing Management and a Professor of Operations, Technology, and Information Management here at the SC Johnson Graduate School of Management, which is part of the SC Johnson College of Business. His research deals with data-driven analysis, modeling, and optimization of problems in retailing and supply chains. And one of his current projects focuses on reduction of food waste in supply chains through technology and analytics, very appropriate for today's conversation. So with that, I will hand it over to Professor Gaur and let him tell us about food waste and CPG.
Thank you, Aaron, and afternoon, everyone, or morning, afternoon, evening, depending on where you are. It's a pleasure to see you all. And Aaron, what a wonderful symposium this is. It's nice to listen to Professor De Gruyter and to Professor Gomez just a short while back. So I'll share my screen and will tell you the story from my perspective. So as Aaron said, I study operations management in retailing and supply chain contexts. And I have looked at food waste over the last 5 or 6 years in this context. So the story that I want to tell you is based on the work that we have done using analytics to solve a problem related to food waste of packaged food products in this context. So to give you a brief background about my work, so in the context of food waste, we have published 2 research papers. One uses a large-scale analytics on data from the supply chain of a food products manufacturer to identify the drivers of unsalables. And I will focus a lot on this story in my talk. And the second one is a paper which gives an agenda for various ways in which food waste can be reduced through better technology and analytics. We also teach on this topic in our classroom. So we wrote a case study called Product Expiration at Health Cola, which we use in the classroom to tell students about the problem of food waste, why it occurs, and what different kinds of methods can be used to solve it. Indeed, the interest in solving food waste problems has been increasing over time. And we can see that in the timeline of major events and organizations that are involved in this. This is a dense picture, but what I take away from this is that for a long period of time, there was relatively less attention on food waste. But during the last few years, we see an increasing amount of attention being given to this topic from nonprofits, from regulatory organizations, and also from companies that have taken on the initiative to reduce food waste in their supply chains in different ways. Our study looks at identifying the root causes of food waste for packaged foods. And the reason why we looked at this problem is because food waste is indeed an extremely complex problem. And you saw the talk by Professor De Gruyter just a short while back, and he was describing a model for how food waste can be contributed from different places in our economy. So one cause can be farm processing, distribution, and in retail also there are many potential causes for the occurrence of food waste. For example, excess shelf space given to an item, or full shelves, or overstocked displays. And there is a trade-off associated with these things, because on the one hand, many of these practices are known to increase sales and profits, but on the other hand, they require more inventory in the store which results in greater food waste down the line. So altogether, this is estimated to be a big problem. So by some estimates, 1 to 2% of packaged food products are wasted, which costs the industry about $15 billion annually, and not to speak of the societal costs and the environmental costs associated with all of this food waste. There are many business decisions that might be contributors towards this food waste problem. So similar to overstocked shelves or excess inventory, commonplace decisions that we take, such as case pack sizes or warehousing of product in an inventory, can be causes of food waste, or even how expiry dates are coded, or the types of policies that are used for date coding can be a driver of food waste. In terms of operations, the damage during logistics, in transportation, the type of packaging, temperature variations, all types of execution issues can be a driver of food waste. So for our study, we worked with a CPG manufacturer that is one of the largest packaged food manufacturers in the world, and that operates mainly through a direct store delivery model. So the company has several products with a median shelf life of 21 weeks. The estimated average expiration rate for unsalables in their supply chain is 0.57%, which might seem small, but if you think about the cost of production, logistics, and reverse logistics associated with this product, and compare it to how much the net profit typically is for a food products manufacturer or retailer, this is equivalent to about 50% of the total net profit after tax made by the company each year. So it's a significant cost for the company. The problem that we address is that the root causes for the occurrence of expiration are generally unknown, or it's not known to what extent do different potential drivers cause food waste. So for instance, incentives are usually misaligned between manufacturers and retailers. And we don't know the extent to which misaligned incentives could be a cause of food waste. So it's common that manufacturers may blame retailers for their practices, and retailers may blame manufacturers for their practices. And we need to use proper measurement using data to identify how much of the occurrence of food waste is caused by factor A versus factor B. So to address this problem, we obtained data from our industry collaborator for 1 year from their entire supply chain. So from their data warehouse, we obtained data on store deliveries, returns, types of returns, warehouse inventory, orders, shelf lives of products, and shipments in the entire supply chain from factories to warehouses, national warehouse, regional warehouses, etc., and to retailers. The data is for their US market. We also obtained from them spreadsheets that contained details about their sales incentive calendars, metrics that they were using, and rotation audits that they had done, and what was found in those shelf space rotation audits. So altogether, this was a massive amount of data. So we had 768 SKUs and 66,867 stores. And this became more than a gigabyte of data. And it was just hard to work with all of the data and do a statistical analysis with it. So we took a smaller representative sample consisting of 10,000 stores and 870,000 store SKU combinations and complete transaction level data for them throughout the entire supply chain to do our analysis. The set of stores in our data set included convenience stores and gas stations, supermarkets, drugstores, mass merchants, supercenters, etc. So we had two research questions in our study. One was, how do factors such as product characteristics, supply chain operations, and store operations contribute towards the occurrence of expiration of packaged food products? The second one was that once we have discovered these factors, which if we were to make improvements to some of these factors, how much impact would that have on the occurrence of product expiration? So using the data set, we estimated a model and tested a few different kinds of hypotheses that I'll describe in the next 6 slides. The first hypothesis was that the probability of expiration of a product is positively correlated with what we called as case size cover, meaning the ratio of the case pack size in which the product is shipped to the mean weekly rate of occurrence of demand for the product in a retailer. So case sizes in our data set varied between 1 through 24, and mean demand per week was varied in a very wide range across products and store formats. So it's possible that, let us say, an item has a case pack size of 24, and that case pack size sells out very quickly in a large size store, but may last for several weeks in a small store, resulting in a greater probability of expiration in a small store. So case pack size was one. The second factor that we looked at was supply chain aging, meaning how many cumulative days has a unit spent in the supply chain before reaching the retailer. So each product has a sojourn time from its production in the factory through the distribution network, through inventory to the retail store. And we measured this using the supply chain data that we had for all of the items and store combinations in our data set. So, and we hypothesized that expiration should be positively related to the occurrence of supply chain aging. The third factor was negligence of shelf rotation. We used audit data to estimate or to measure which shelves were rotated and which were not rotated. And this is considered to be a big factor in the occurrence of expiration. So we looked at this carefully. The fourth one was compliance to minimum order rules, because small size stores will often increase their order size to comply with the minimum order rule, which can result in greater inventory in the store, which then contributes towards potentially having more product getting expired. The fifth one was manufacturers' sales incentives, because our industry collaborator had 9 different incentive programs in place according to a calendar. So we wanted to assess the effect of each incentive program using its calendar on the occurrence of expiration. And the final one was forecasting complexity for the DST route drivers that were replenishing the shelves. That some drivers had very complex routes involving a large number of replenishments, whereas others had shorter routes. So we used that as a factor to assess the forecasting complexity. Now, one of the technical problems we faced here is that a product doesn't expire the moment it reaches a retail store. So tracing the cause of expiration is not easy, because a product may expire today, and if I look at it today, by looking at the product, I cannot tell which of these causes may have been responsible for that product to expire. The product would have been manufactured some time back, and then it would have gone through a journey in the supply chain, reached the retail store, and then experienced different things along the process. So all of that needs to be captured in a model appropriately. This is my only technical slide, and the only purpose is to say that that this is a complex problem, and we fitted many different models to our data to see which model fit the data in the best possible way. And a model called a zero inflated negative binomial distribution fitted our data in the much better than any of the other models. So that's what we adopted. On this slide, I'm summarizing all of the results of our study. It is color coded, and I'll walk through it gradually. So one thing that we found was that the occurrence of expiration depended on what format of store it was. So as you notice here, drugstores and warehouse club stores had the highest amount of expiration or occurrence of unsaleables, but for different reasons. Drugstores because they have more slow-moving merchandise, and club stores because they receive much larger shipments each time product is shipped. On the other hand, grocery stores had the lowest amount of product expiration due to unsaleables, and the other types of retailers were in the middle. So this is one observation. The second observation is that case size cover indeed was a big factor in causing expiration. Supply chain aging was also statistically significant. Shelf life of products, which we controlled for, is significant as well. Minimum order rule cover mattered. Demand variation or uncertainty in demand or forecasting complexity had a big impact, but it did not turn out to be statistically significant in our model. Surprisingly, rotation was not statistically significant either. However, there were some sales incentives that seemed to have a huge significant impact on the occurrence of expiration. So these were the results. I have a couple more slides to present, and then I'll pause for questions. So using these results and the negative binomial model, we then decided to do a counterfactual analysis to assess how much improvement would take place if some of these factors were changed. So for example, if I reduce case pack size for certain products from, let us say, 24 to 12, then using our estimated model and our data set, we wanted to estimate how much saving in food waste would be realizable from that managerial change. This is something that is generally not, this type of data is generally not available to managers because such estimates are not available. So because we had the entire supply chain data, we were able to construct such estimates. So we wanted to use those estimates to provide some type of a guidance to managers who may be thinking about how to incorporate food waste considerations in their operational decisions in the supply chain. So here are the results from this counterfactual analysis. So what we found was that if we take products whose case pack size is 24 and reduce it to 12, then this change impacts 35.8% of the volume of items in our data set. The monetary impact on the occurrence of unsaleables is $2.8 million from this change. Okay, so this was a big factor that affected, that could play a useful role in reducing expiration. And this data can be used by managers to trade off the cost of reducing case size with the benefit on food waste that they could realize through that. Similarly, we reduced supply chain aging in our data set for those SKU store combinations that had very high supply chain aging. We reduced, or higher than average, we reduced it by half a standard deviation. This impacted 22.5% of the observations in our data set, and doing so from using our model would have resulted in a reduction in waste of $1.78 million. The third factor is minimum order sizes. And so we simulated what would happen if orders were not inflated to reach minimum order size, and found that this impact was $1.7 million of reduction in food waste. And then finally, the three Salesforce incentives that were the biggest drivers of food waste, if they were eliminated, then we found that that would have so much impact on the reduction of food waste. So, this is a quantification of impact on corporate cost and profits. We all know that there are other societal benefits and environmental benefits of food waste reduction. Those are not captured here. So the focus is only on the impact on corporate revenues and costs and profits. The total benefit from all of this is estimated to be $40 million saving in cost and 1.9 million fewer expired cases annually from this study. So just to conclude, food waste is costly. Reducing food waste is a very difficult problem for many reasons. There are methodological barriers in measurement. There are incentive misalignments in the supply chain. And sometimes the organizational structure also impedes in initiatives to be considered for food waste reduction. However, analytics and technology are presenting new powerful methods to reduce food waste. So here you saw an application of analytics using data for the entire supply chain to identify solutions. Our model and our methodology can be refined with more new kinds of data. So for example, when we measure supply chain aging, if supply chain traceability data is present, then it can be used to create new algorithms for how to replenish retail stores, and which items to send to retail stores and which not to send to retail stores. Even incentives can be realigned because we'll have much more information on what factors cause or what actions lead to food waste and are maybe otherwise unproductive in a business. So, and it is possible to build on this and create new business models and new methods for handling logistics. So those are some of the things that we are currently working on in this research. So, so with this, I'll thank you for listening to my long monologue, and I'll be happy to take any questions if there is time.
Thanks, Vishal. This is fascinating. I think we've got a couple questions in the chat, and then I have a couple questions if we have time. But I'll start with the chat. One of the questions was if the financial clarification, if the financial benefits in the previous slide were for the manufacturer or to different parts of the supply chain. Those benefits you quantified, yeah. Who are they for?
The benefits I quantified are for the entire supply chain. So they would have to be allocated somehow between the manufacturer and the retailer, which would depend on what type of reimbursement policy the manufacturer uses with retailers. Great,
thank you. So I was just wondering, just looking at this, it occurs to me that, I always, my initial prior was that maybe managers weren't necessarily prioritizing food waste because there was like you said, a misalignment of incentives. But it seems to me like there's a pretty compelling cost savings argument here that may not. So is the issue here the lack of being able to measure these data and establish metrics, or is there truly a misalignment in the sense that a manager has to be sustainability focused to want to do this? What would you say is sort of the tension here?
Yeah, I would say that the main source of tension here is the lack of measurement, because retailers typically look at their own data and manufacturers look at their own data, and common industry practices to ascertain the root causes of damage or expiration, etc., are based on audits. But if I look at an expired can of soup or a damaged can of soup, Through an audit, if it is damaged, I can tell how the damage might have occurred. But if it is expired, then just by looking at the can, I cannot tell what factors may have led to its expiration. And in fact, in industry surveys, oftentimes unknown is the category that is most commonly noted for expiration. So I think the step that we took here was to use the data from the entire supply chain and integrate it so that we could take the can of soup and look at it going backwards in time as to what were the different causes of what was its journey and which of those factors in its journey can we attribute this expiration to. I think so. That's the approach that we took. And I think this is the way to go to improve measurement. And if we have proper measurement, then it would help us address the incentive misalignment issue that you described, Aaron.
Excellent. Thank you. I think we're right at time, so I'll wait 1 second if anyone has any additional questions in the chat. Otherwise, maybe we'll continue this conversation in the roundtable. So I'll just give 1 more second in case anyone has a last question. Okay. Well, Vishal, thank you so much for the presentation. This is fascinating. I think I've got a lot we all have a lot to think about. Actually, Kai has one question. We'll get that one in first. Her question was, what would you suggest the company do to get better data on the causes instead of just having that unknown? Does this require sort of a collaboration across the supply chain, or can a single firm actually take some action to improve their data quality?
I think a single firm can take some actions to improve its data quality. But let us say the single firm is a manufacturer, then the manufacturer won't know if a can of soup expired, then when was that can of soup shipped? So whereas if it's a retailer, then the retailer won't know when was that can of soup shipped between the manufacturer to the retailer. So there are some blind spots in data collected by a single company. Supply chain traceability can address those blind spots, but if we don't have full supply chain visibility, then I think we do need to integrate the data across at least 2 adjacent tiers of a supply chain to get somewhere with this. Yeah, but I'm happy to, I think it's an important problem, so this may not be the only solution, and others here may have other solutions in mind.
Great. Thank you again.